I'm Roland Minton. These are some of my favorite math stories. In this episode, Mathematics is Shakespearean. We'll look at some of the interesting examples from Rob Eastaway's excellent book, Much Ado About Numbers, Shakespeare's Mathematical Life and Times. While little of what Shakespeare wrote could be called modern, high-level mathematics, Eastaway immerses us in the culture of Shakespeare's times and shows the bard on the cutting edge of the exciting developments in math and science around 1600. If I write 6 star 8 or 6x8, you understand that I'm multiplying 6 times 8, and you'll get 48. Without using a calculator, I hope. Why do we use the x symbol for multiplication? Well, it comes from a clever trick for multiplying numbers 6 through 9 that Shakespeare probably learned in school. Here's the diagram that he would have used for 6 times 8. Stack up the 6 and 8, and form a second column of the numbers needed to add to 10. So 6 plus 4 is 10, 8 plus 2 is 10. Connect the diagonal elements with an x. Now we have smaller numbers on the right, which we should know how to multiply. 4 times 2 is 8. The difference between a pair of numbers connected by the x is 4. Both 6 minus 2 and 8 minus 4 equal 4. Take the 4 and the 8, and you have the answer, 48. You should try this with some other number, maybe 7 times 9. What happens if you use numbers not between 6 and 9? Well, let's look at 3 times 6. Stack up the 3 and 6. 7 and 4 are the complements needed to make 10. Put in our x. Now we'll need to know 7 times 4 for the ones digit of the answer. Of course, if we know 7 times 4, we probably know 3 times 6. And 7 times 4 is 28, not a very good units digit. The difference along a diagonal is 3 minus 4, or 6 minus 7. That's negative 1. That's the tens digit, but negative 128 doesn't make much sense unless you think of it as negative 10 plus 28. That's 18, which is, of course, the answer. You can verify that the trick always works, though it is only really convenient to use for digits 6 through 9. To multiply a times b, write out a and b in the column, 10 minus a, 10 minus b next to it. Put in the x, we'll compute 10 minus a times 10 minus b, and then a diagonal would be a minus 10 minus b, multiply that by 10. If you multiply that all out, you will get a times b. I think that's pretty neat, but did Shakespeare use it in his work? Hard to say, but in the course of his wordplay, he did some nice arithmetic. In Othello, the following are equated by an impatient lover: a week, 7 days, and 8 hours. I know mostly from Lincoln's Gettysburg Address that score means 20, so 8 would be 160, and the unspoken plus before the second 8 makes 160 plus 8, 168. How many hours are in a week? 7 times 24 is 168. Shakespeare knew his arithmetic. In Love's Labour's Lost, a money negotiation equates 3 farthing with halfpenny farthing. Now, a farthing was a quarter of a penny, so 3 farthings would be 3/4 of a penny. There's again an unspoken plus to account for halfpenny farthing. The halfpenny plus farthing quarter penny, half plus a fourth is 3/4 of a penny. Wordplay with the addition of fractions. Who knew? Gambling makes several appearances in Shakespeare's plays. The main games of the day were Primero, essentially 4-card poker, and Hazard. In Hazard, 2 or 3 die are rolled, and bets are made on the total of the die. In Shakespeare's time, an argument was made that in 3-die Hazard, the 9 and the 10 should be equally likely, because each can be formed in 6 different ways. Here they are. 9 is 1 plus 2 plus 6, and 2 plus 2 plus 5, and so on. Here are 6 ways of writing out 10. However, savvy players knew that 10 occurred more frequently than 9. Can you look at that listing to see why 10 is more likely? Well, the first 5 pairs of entries are all equally likely, but 334 is more likely than 333. 334 could be that way, or 343, or 433. The 4 could occur on any of the 3 die. Eastaway notes that the problem was solved by, of all people, Galileo in 1620, 4 years after Shakespeare's death, although The Secret was not published until 1718. In The Merry Wives of Windsor, In The Merry Wives of Windsor, Shakespeare references all the colors of the rainbow. This is interesting because in popular thought at the time, the rainbow only had 3 colors. Referencing all the colors means that Shakespeare thought there were many colors. The idea of 3 colors descended from Aristotle, who needed the number to be 3 for aesthetic reasons, 2 extremes and a middle. Shakespeare had a severe handicap in knowing our colors, Roy G. Biv, red, orange, yellow, and so on, although discoveries from his time were clearing up many ideas about the rainbow. In particular, orange was not thought of as a color. It was a fairly rare fruit in England, but eventually became more common and donated its name to its otherwise anonymous color. Chaucer, for example, very unpoetically described the hue of a fox as, quote, a color between yellow and red. About a century later, Isaac Newton wrote the influential book Optics, with many insights and discoveries. He identified 7 colors in his rainbow, although a graphic he used makes it clear that he needed 7 colors to match the 7 notes in a musical scale. Of course, we think that there are an infinity of colors, so Shakespeare's expression makes sense to us. As I hope these examples show, Much Ado About Numbers takes some mathematical and scientific aspects of Shakespeare's work and adds historical context. If you find the above bits interesting, I strongly encourage you to read the book. The final topic I'll address here is the advent of the lead pencil, which occurred during Shakespeare's time. The lead graphite used came from nearby Borrowdale in England. The standard of the day was to sketch out ideas in lead, which could be erased with a wad of bread, but important and final documents had to be done with ink and quill. A recipe for ink, which Shakespeare may have used to make his own ink, is given in the book. On the occasions when Shakespeare used lead, he probably would have had access to that high-quality lead from Borrowdale, grading out to at least 2B and maybe as high as 9B. So, for Shakespeare's pencil, the question is, was it 2B or not 2B?